only, sir, who will set up that power? Means just we are discussing that power. Now, which all forces can generate a power? Next question. So I'm going to explore things now. Okay, spring force, can it generate a power? Conservative force can generate a power is what the first thing. So I'm beginning like this here. So there's a spring block system. What is our next discussion? Power generated by the various types of forces. So first I'll begin with a simple spring force, because already you have enough idea of spring. No? This is the equilibrium or natural length of the spring. Now the spring is elongated by how much? A distance x naught, and a release from rest here. The block is pulled by distance x naught, so the spring will get elongated. So spring force will act, and it is released from rest. That's what the question is telling. Release from rest. Now the spring force does positive work, and it's a conservative force. So when the displacement of the block is at a distance x here, if x is instant deflection of the spring from its natural length, is it okay? Fine. The diagram, and how much of spring force? Kx will be acting. And according to the idea what we know, the force into the velocity will be the instantaneous power. So first, how to get that V? Conservation of mechanical energy. Kx naught square by 2 should be equal to kx square plus mv square. So what is the expression for V? V should be equal to instantaneous power generated. This 2 will get eliminated. So this should be.
So the spring has been compressed.
No problem. Compressed or elongated, no problem. Instantaneous deflection of spring. Deflection means, what do you mean by deflection?
No, sir, in the first case, it's not elongated, it's compressed.
It doesn't matter, no? Elongation, compression doesn't matter. I can take it, no problem. You have to shift this block here. That's the only thing, that one. So I think problem doesn't make much a difference. Only thing is the block should come here in this position. The block should be here, somewhere here. If I release it, then come somewhere here. Diagram a little bit congested. That's why I just made elongation. If you want, I'll change this word. Okay. No, the instantaneous power developed here. So this should be equal to how much? This is the speed of the block. Then what is the instantaneous power generated by the spring? P equal to spring force into speed. Spring force kx into v. So definitely I think option A will not come into picture. See how we define instantaneous power. We should not define instantaneous work is a meaningless quantity. I think you have to be very careful. Instantaneous power defined, average power defined, work done is what? Force into displacement. No, the displacement to occur, what happened? There some finite interval of time should occur, that one. So therefore instantaneous work is not all defined here. Say work done is defined for an event, not at that instant. So instantaneous work is quite meaningless. We don't have any such physical quantity. So you have to be careful in exam. Now this is about the power. So instant power developed. Okay, we can't pick up the option A. Now it's asking the maximum power. So can we differentiate this? dP by dx is equal to. So I'll differentiate this. I'll equate to 0. Then I'll check at what position the power will be the maximum. Can you manage this mathematics? How to calculate that maximum power? Differentiate this given equation with respect to x equal to 0, then you'll get the position at x equal to certain value in terms of x naught. There the power will be maximum. Why is bringing the idea of maximum power? Means maximum power occurs. Tell me, where do power generated by spring at extreme, 0 or non-zero? Power generated by spring on the block at extreme, 0 or non-zero? 0, no? It mean, don't repeat again started, don't repeat. Power generated at extreme will be 0 by spring on the block. Power generated by spring at mean position on the block will be 0, because here what happened, the spring force will be 0 at mean position. The spring force will be 0 here. Clear this? Here the spring force will be 0, maximum velocity. So power generated by spring on the block at mean position will be 0. Power generated by the spring on the block at extreme will be 0. And somewhere it keeps on increases, becomes maximum, then decreases. So when a spring block system, there in a spring block system as the block oscillates, the power exerted by the spring on the block, constant or variable, it varies. That's why the word maximum he has brought it. If it were constant, no, I would have not brought that maximum.
Sir,
Uh,
sir, why is it 0 at maximum elongation, sir?
Velocity is 0, no, at extreme point.
Okay, sir.
At extreme point, velocity is 0. At mean point, force is 0. So therefore, the power delivered by the spring on the block at extreme and mean will be 0. And as
Okay,
it moves, tell me this spring is what giving energy to the block, no? So the rate of kinetic change of block, shall I say, equal to the power generated by the spring? Can I correlate the words? Rate of change of kinetic energy. The rate of change of kinetic energy of the block should be equal to the rate at which potential energy decreases. Both are same, or power generated by the spring force. So what is this system? The elastic potential energy is getting converted into kinetic energy. With time, we are linking this one here. So don't call elastic power. Instantaneous power developed in spring. We should not use word again, elastic power. Nothing to the rate at which potential energy decreases, that is getting converted into increase in kinetic energy of the block. So the energy conversion occurs in over an interval of time. Therefore, the idea of the power has come. Anybody value maximum where the power will be maximum? At what position? Differentiate this and equate to 0.
So I got none of the above, sir.
No.
Options.
Check calculations once. At what position the power of the spring will be maximum? That position is asking in terms of x. In terms of x naught should be there.
Sir, is it option C?
I'm you have to confirm. I'm not sure. By calculation, you're supposed to tell, no? Not by looking at the. Anyway, just calculate tablet and tell it.
Sir,
Uh,
I got x is equal to root over of 3k square by 4m into x square, sir. All inside the
Where
root.
will get an option C?
Option?
C, sir.
Option C.
Latest one.
At this position, the power generated by the spring will be maximum. Okay, this one. So this value of x, you substitute, you'll get the maximum power. Where the rate of transfer of energy by the spring to the block will be maximum. Another sense of expressing where the transfer of rate at which the energy gets transferred by the from the spring to the block will be maximum at x equal to x naught by 2. This is a meaning. There's a transfer of energy occurs from the spring to the block as it moves from extreme to mean, where it will be maximum at this position. There's a meaning of that.